Hello, in this video, I will explain to you on how to solve this problem. Let's read the problem first. In figure 27.23, R1 is 6 ohm. Okay, maybe let's label that. R1 is 6 ohm. And then R2 is 18 ohm. So I will have 18 ohm here. And then here is also 18 ohm. And here is also 18 ohm. Okay, good. And the ideal battery has EMF of E is equal to 12 volt. So I will have this as 12 volt. And then the question are, what are the size and direction of the current I1? Okay, the current I1 is here, and we need to find out the direction and how much energy is dissipated by all four resistors. Okay, let's see here what can we do in this circuit here. Let's see here. If we name this node here as node A and this node here as node B, we see here all the resistor here, this one, and this one is connected to that nodes A and B. What does that mean? That means that all of this is in parallel, right? So this part here is in parallel. So we can replace all of this by using a single resistor. How to do that? Remember the formula of the parallel resistance. I will have 1 over R equivalent is equal to, I have 3R2 here. So I will have 1 over R2 and then plus 1 over R2. Here this resistor, and this also 1 over R2. 1 over R2. But then R2 is 18. So let's plug that in. So I have 1 over 18 plus 1 over 18. And then plus 1 over 18. And so that will be 3 over 18. But that is 1 over R equivalent. To get the R equivalent, we can just flip that. Right, so I will have 18 divided by 3. We can just flip the fraction, and then that will be 6 ohm. Good. We have our R equivalent now. Now let's redraw the circuits using a single resistor. So let's redraw it. So we will have this E here, this battery with the 12 volt EMF. So I will have plus and minus. This one will be our 12 volt. And then we will have this resistance here, and that will be 6 ohm. Good. And here we will have our R equivalent. Okay, we'll have R equivalent, right? Because we replace this part with parallel resistance, and that will be 6 ohm. Good. Now we have a simplified circuit here. Now what can we do? Let's assume the direction of the current. I just assume this battery giving current to the circuit here, and let's name that current as I. And so the current that passed through this resistor is also I, but then this will be goes here, right? It will cycle around. Okay, so we can use the loop rule at this loop here. Let's name this loop as loop 1, and we can do a loop rule. Let's apply the Kirchhoff loop rule to loop 1. Okay, and the Kirchhoff loop rule said that the sum of the voltage in a loop will equal to 0. However, we have to be very careful about the sign. Okay, for the battery, the long one here is the positive one, and the short one is the negative one. But for the resistor, where the current comes from is the positive one, and where the current goes to is the negative one. And again here, where the current comes from is the positive one, and where the current goes to is negative one. Okay, let's apply the loop rule here, and let's start from this 12 volt battery. Here the loop entering the negative side, so I will have minus here. So I have minus, And then the voltage. What is the voltage? The voltage is 12 volt. So I will have minus 12. And then I will have plus. Why plus? Because it enters the resistor here from the positive terminal. So I will have plus, and then we need voltage. But the voltage is the current multiplied by the resistor, right? This is the Ohm's law. Okay, so we will have the resistance is 6 ohm and the current is I. So we can just multiply them to get the voltage. Okay, now let's move on to this 6 ohm resistor, and it enters from this positive terminal here. So I will have positive sign. And again, we can get the voltage by multiplying resistance and current. So I'll have 6I. Good. All of that will equal to 0. And then we will have minus 12 plus 12I. That will equal to 0, or 12I is equal to 12. And so we will have our I here is 1 ampere. Okay. But then that is in our simplified circuit. Here we will have our I like this here, and our I here is 1 ampere. Okay, and that will be very important value here. However, we need to do some more calculation to calculate I1 here. Good. Okay, now let's clean up our slide. Okay, here maybe let's assume the direction of the current for the current that pass through all the resistance. Maybe this will goes to the right, and this also goes to the right, and this one will goes down like this. Good. And let's see here. AB is in parallel. Remember, in a parallel circuit, the voltage will be the same, right? So I have plus and minus here. So remember the Ohm's law, I is equal to P divided by R. But then if our P is all the same and our R is all the same, right? So we will have R is all the same because this is R2, R2, and R2. So we will have the I also the same. So this current here is also I1, and this current here is also I1, and this current here is also I1. Okay, why that is important? Because we can apply the current, the Kirchhoff junction rule, right? Let's apply the junction rule at A. Okay, and the junction rule said that the sum of the current that goes in will equal to the sum of the current that goes out. Good. And what is the current that goes into node A? This current, right? That is I. So I will have I, and then all the current that goes out, I will have I1, I1, and also I1. So we'll have I1 plus I1, and then plus I1. Good. And then we will have I is equal to 3I1. But then our I here is 1 ampere. So we'll have 1 is equal to 3I1. And so we can calculate I1 here, which is 1 over 3 ampere. Or in decimal, we will have I1 is equal to 0.333 ampere. Okay. And then what is the direction? Because this is positive, the direction is from left to right, right? So I have left to right. So we have answered the question A and B. However, we still need to find out how much energy is dissipated by the all resistors. So here that is the answer for question A and B. But for question C, we need to see at this simplified circuit because energy is equal to the power multiplied by time, right? So what is the power? The power is I squared multiplied by R multiplied by T. Okay, And what is our I? 1 ampere. So I have 1 square. And what is our R? Our R is 6 ohm and 6 ohm in series because we have all 4 resistors in here, right? So I will have 6 plus 6, and then time. Time is 1 minute, but we need to do it in SI unit, right? So T is 1 minute, and how much seconds in 1 minute? That will be 60 seconds. And so we will have this multiplied by 60. So we will have 36 multiplied by 60. And so we will have, what is 36 multiplied by this? I think that will be 2160. And the unit here will be joule. And that is our energy. And that is the answer for question C. So we have all the answer for this problem. Thank you for watching. See you in the next video. Bye bye.